Today we will study elementary row operations on matrices. Okay, we have three operations, row operations. First one is permute rows. So we can, for example, we can permute rows. Let's say that we have a matrix 1, 2, 4, 5, minus 1, 0. Then what we can do is permute R1 and R3. So we will write R3 in the first row. So we don't touch second row, and then we write the first row in the third row. So we permute the first row and the third row, and we write R1, R3. R1 goes to the place of R3, and R3 goes to R1. And the second elementary row operation is, so this is the first one, example for the first one. And the second elementary row operation is multiply a row with a non-zero constant. Okay, let's give an example. For example, if we have again the same matrix for 5, minus 1, 0, we can multiply, let's say, first row with minus 2 R1 and write again into the first row. So minus 2 R1 minus 2 times minus 4, and we don't do anything to the other rows. So we can multiply with any non-zero constant. So, and the third elementary row operation is add a multiple of one row to another row. Okay, here, for example, what we can do is, okay, let me give the same. 4, 5, minus 1, 0. So what we can do is we can multiply the second row, let's say minus 2R2 plus, and we can add to the third row and write to the third row. Okay, maybe I should write like this. So we don't do anything to the first row. So we multiply minus 2 R2 and plus R3. So we don't do anything to second row also. Then minus 2 times minus 4. Minus 2 times 4. Minus 8 minus 1. So we have minus 9. Minus 2 times 5. And we add to the third row minus 10. So minus 9 is 4 times minus 2 plus minus 1. And then 10 is minus 2 times 5 plus 0. And then we write to the third row. Okay, and we have a definition. We have this definition, a matrix, a square matrix. So we have n by n matrix. Any matrix obtained from A by a finite number of elementary row operation is called row equivalent to A. Okay, let me give an example or row equivalent to A. Okay, we have row equivalent to A, and we have one more thing. So we have row echelon matrix. So it is called, what is row echelon matrix? And n by n matrix. N by n matrix is called a row echelon matrix if there are any rows consisting of zeros. They are grouped together at the bottom of the matrix. So these are at special forms. So if you have any zero rows, so all the entries are 0, then they should be at the bottom of the matrix. And first non-zero element in any row must be 1. So this is a leading one. It is called a leading one. And the leading one of any row below the first row is to the right of the leading one of the row above it. So if you have a leading one in somewhere, then any other leading one is to the right of this leading one. Okay, let me give examples. You will understand better. Okay, for example, so row echelon matrix. Let's say I will just made it up some examples. -1, 0, 0, 1, 1, 2, 3. So this is, for example, we say, so this is contradicting to the first one. We say any rows consisting of 0, they are grouped together at the bottom of the matrix. So this, we have a row here, 0, 0. It should be, so this is not a row echelon matrix. And okay, another example. So okay, let me give another not echelon matrix, and then I will give more not echelon matrix. Okay, for example, this one is also 1, 0, -2, 0, 1, -1, 0, 1, 3. Because of this third rule, so we say that the leading one of any row below, so we have leading one here, so we have leading one here, but this should be the right of, so it is just below the leading one. If we have one here, then we would have a row echelon matrix, but because it is not to the right of the leading one, we have not row echelon matrix again. Not row echelon matrix. Okay, let me give echelon matrices. Like, okay, we have 0, 0, 1, 0, 0. As you can see, all the zeros are at the bottom, and we have one leading one. So this is a row echelon matrix. Or for example, 4, -4, 5, 0, 0, 1, 3, 0. You see 0, 1, 3, 0. So these are row echelon matrices. As you can see, if we have zeros, they are at the bottom. So leading one, all the leading ones are to the right. You see 1, 1, 1. So these are row echelon matrices. And every matrix can be reduced to a row echelon form. So okay, let us give some use elementary row operations to find row echelon form of the matrix. So we will put this matrix into row echelon form, -1, 1, 3, 0, -1. Okay, maybe you will understand better. Okay, so what we can do is 1, 2, 3, 2, -1, 1, 3, 0, -1. And so we say first non-zero element in any row is 1. So we are lucky, in the first row we have 1. But so if we arrange this to be 1, like this, you see we have in the second row we have 2. But if it is going to be below the leading one, it should be to the right of the leading one. So we should arrange these to be 0, and this entry to be 1, and this entry to be 1. Okay, what we are going to do is, so we will arrange, okay, so these are to be 0. So how can we make this to be 0? So what we can do is, if we multiply with -2 to the first row and add to the second, and we will write in the second row. So minus 2 times 1 plus 2, we will get 0, right? And what we are going to do is we multiply the first row with minus 3 and we add to the third row and we will write it to the third row. Okay. And what we get, so we have 1, 2, 3, and then we multiply the first row with minus 2 and add, we will get 0. Minus 2 times, but don't forget the other ones. Minus 2 times 2 plus minus 1, so we will get minus 5. Minus 2 times 3 plus 1, so we will get minus 5 again. What about the third row? Minus 3 times 1 plus 3, we will have 0. Minus 3 times 2, minus 6. Minus 3 times 3, minus 9, minus 1. So we have minus 10. And in the row reduced echelon form, first non-zero element in any non-zero row is 1. So we should arrange. Okay, first row, first non-zero element is 1, right? So that is okay. What about second row? Second row, we have 0, minus 5. So minus 5 is the first non-zero element, but we should have 1 there. So we should arrange minus 5 to be 1. So how can we make this to be 1? How can we make this to be 1? So the easiest thing is we can divide, right? We can multiply, we will divide R2 with R2. Right, great. One, two, three. So we will multiply with minus 1 over 5. We will get 1, 1, 0, minus 6, minus 10. So here again, if you see the third row, if we arrange this to be 1, then we will be contradicting to this third condition. So the first row is to the right of the leading one. So any leading one must be to the right of the leading one. So we should make this minus 10 to be leading one and this to be 0. So how we will make this term to be 0? What we can do is, so we will multiply 6 times R2 plus we will add to the R3, right? And we will write it to R3. So we have 1, 2, 3, 0, 1, 1, 0, 6 times R2, 6 plus minus 6, we will have 0. 6 plus minus 10, we have minus 4. So we are almost there and we need to be, arrange the last row. So first non-zero element in any non-zero row is 1. Okay, in the last row we have minus 4, but we should arrange it to be minus 1. So how we are going to do that? So we will divide by or multiply by minus 1 over 4 times R3 and we will write it to be R3. So we have 1, 0, 1, 0, 0, 1. So this is the row echelon form of the given matrix. Okay, we find the row echelon form. So also we have another form. It is called row reduced echelon form. In this row reduced echelon form, we will see only ones or zeros. So here you see we have 2 and 3 and we have 1 here. In row reduced echelon form, okay, what is the definition? Reduced row echelon form, sorry. What is reduced row echelon matrix? an n by n matrix is called a reduced row echelon matrix if it is a row echelon matrix, first of all, and any column that contains the leading one has zeros everywhere else. So, okay, let me give an example. Okay, example is here. Okay, 1, 2, 3, 0, 1, 1. So the matrix we found is a row echelon matrix. But not row reduced or not reduced row echelon matrix. But we can make it into a, so we will arrange any column that contains a leading one has zeros everywhere. So we will get rid of this 2, 3, and 1 easily. So how we are going to do it? Always we will start from the bottom. So we have leading one here, we have leading one here, and we will arrange these to be 0. So how we can do that? So we can minus 3 minus R3 plus R2, and if we write it R2, we will get 0 over there, and minus 3 R3 plus R1, and if we write it to R1, we will get 0 also. So we have 0, 0, 1. We multiply with minus R3 and we add it to, so 0 times minus 1, 0 times minus 1, we will have, 0, but here minus 1 plus 1, we will get 0 here, and we have 1, 2, 3, 1, 2, minus 3 times R3, minus 3 plus 3, we have 0 here, and we have only the second column, we have 2 here, and how we make it 0, how we will make it 0 is, we will, minus 2 times R2 plus R1, we will write it to R1, and what we are going to get is 0, 0, 1, 0, 1, 0, 1, 0, 0. So we find the reduced row echelon matrix, which is row equivalent to this matrix, this given matrix. Great. And if we have a matrix A, so let A be an n by n matrix, and if there exists an n by n matrix A inverse, we call it A inverse, such that if we have A times A inverse is the unit matrix, or we have A minus 1 times A, then the matrix A minus 1 is called the inverse of A. So the only square matrices have the inverse, because also we define the this unit matrix to be, if you remember, this I is, it has diagonals 1 and zeros everywhere. So this is the unit matrix, n by n unit matrix. Great, and we have this Gauss-Jordan technique to find the inverses. So it says that if you have the matrix A and you write the unit matrix to the right of A, and then you find the using row operations, you find its row echelon, reduced row echelon form. And reduce it to this first part to the unit matrix, and then in the second part you will find the inverse of, so reduce row echelon form. And we will find the inverse matrix easily using this way. Okay, let me give an example. So what do I mean? Okay, find the inverse of A using, let's say that we have A is given as 1, 3, 1, 2. Oops. Find A inverse by using Gauss-Jordan technique. So this is a 2 by 2 matrix. So we will say that we will write A in this way and find the row reduced echelon form of A, and at the end we will find the A inverse. Okay, what do we mean by that? We will write the matrix A 1, 2, and next to it we will write the unit matrix, and we will arrange, we will make this to be row reduced into row reduced row echelon matrix. Find the reduced row echelon matrix. How we do that? So we need to arrange this 1 to be 0. So how we do that? We minus R1 plus R2. We will write it to R1. But don't forget to make it to the other sides also. 1, 0. So we multiply the first row with minus 1, add to the second row, we will have 0 in. Minus 3 plus 2, we will have minus 1. Minus 1 plus 0, we will have minus 1 here. 0 plus 1, we will have 1 here. And then what we are going to do is we will arrange this minus 1 to be 1. So how we are going to do that? What we are going to do is we will multiply minus R3 and we will write it to R3. So we have 1, 3, 1, 0. And we have 1. We will multiply. Don't forget the other side with minus 1. Great. Now what we are going to do is we are going to arrange this to be 0. Okay, let's do it. How we are going to do that? So we will multiply minus 3 R3 and add to R1. Okay, let's do it. 0 times, okay, we have 0 and add it to 1. 1 times minus 3 added to 3, 0. 1 times minus 3 and we will add it to 1, so we will have minus 2. Minus 1 times minus 3 and we add 0, so we will have minus 3. So here we find the, so this is A inverse. Okay, let's check. So if we multiply, with A, we should get identity, right? 1 minus 1. So this is A times A inverse. We should get 1, right? So, okay, so unit matrix. 1 times minus 2 plus 3, we have 1. Minus 3 minus 3. So we have a problem here. So where did we do wrong? Because we should get 0 here, right? So where did we do wrong? So minus 3 minus 1, 1, minus 1. Yes, that's correct. We should have plus 3 here, right? Okay, I find where did we wrong. Okay, I will make it with, so we have minus 3 times minus 1, so we have 3. Plus 0, we have 3, so this is plus 1. Okay, then we have 0, right? Great, now it is correct. And what about the second? 1 times minus 2, 2 times 1, we have 0. 1 times 3 minus 2, we have 1. Great. Sorry about that, we have identity. Thanks God, we checked it. Okay, let's do another example. 3 by 3, find a inverse where A is, okay, we have 1, 0, 1, 2, 1, 1, 2, 1, 2. Okay, what we are going to do is we will write A 2, 1, 1, 2, 1, 2, and then we will write the identity matrix. In this case, we have the 3 by 3 identity matrix, and we start to arrange. Okay, we have leading 1 here, so it is all right. So we will arrange these to be 0. How we can do that? So we will multiply first row with minus 2 and add to the second row. First row with minus 2 and add to the third row. So what we are going to get is 1, 0, 1. Don't forget to do the other side. Minus 2 times 1, so we have 0. We have 1. Minus 2 plus 1, we have minus 1. Minus 2 times 1, we will add here, and then we will get 1, 0. So minus 2 R1 plus R3. So we have 1 here. Minus 2 plus 2, we will have 0 here. We will get minus 2 here, 0, 1. Great, we are lucky. We have 1 here. It is okay, but we need to arrange this to be 0. So let's do that. 1, 0, 1, 1, 0, 0, 0, 1, minus 1, minus 2, 1, 0. And how we are going to do that? So we are going to multiply with R2 with minus R2 plus R3. We will write it to R3. And then minus 1 plus 1, we will get 0. Minus minus 1, it is plus 1, so we will write here. And we will multiply with minus and add to this here, we will get 0. Minus 2 plus 0, we will multiply with minus 1 plus 0, we will have minus 1. And then we have 0 here. We are almost done. Now we will arrange these to be 0. Well, it is easy, right? So we will add R3 plus R2, and then we will add minus R3 to R1. 1, 0, 1, 1, 0, 0. Oops, sorry. I should write 0, 0, 1, 0, minus 1, 0. Okay, we will add, and then we will get 0, minus 2, minus 1. We will add this to minus 1 plus 1. we will get 0, minus 1 plus 0, we will get 1, and we will add minus R3 to R1. We have 0, it is 0, minus R3, so 1, and we have 0. Great, so we find identity here, and this should be A inverse. It looks wrong again. It looks wrong again. Why it is wrong? Because here, you see, I forget, I write 0 here. So this should be 1. Then does it make a difference? I mean, did I do it wrong? R3. Yes, then I should do this again. I am so sorry. I am so sorry. Okay, I need to. Sorry about that. Okay, let's do it again. Sorry about that. 0, 0, 1, 0, 1, minus 1. Okay, R3 plus R2. 0, 1, 0, minus 2, 0, 0 plus. So we have 0 plus 1. We should have 1. 1 there. And then minus R3. Minus 1 plus 1, we have 0 here. Minus, so we have 1 here. Minus 1 times minus 1, we should have 1 here. Minus 1 here. So this should be A inverse. So we have A inverse, we find it 1, 1, minus 1, minus 2, 0, 1, 0, minus 1, 1. Great. Now if you multiply A minus 1, we should get the identity. Okay. Please check it. So check, this must be correct inverse.